Hey everyone, MindFlareRetro here, and yes, it still is Septandy, and I am fashionably late to the party, but better late than never, I suppose. When Mr. Lurch of Mr. Lurch's Things invited me to participate in Septandy 2020 back in July, yes, July, I excitedly and nervously accepted. However, I was determined to be all in. I immediately started looking for and found a Color Computer 2 on eBay that was listed for parts not working, and luckily I had the winning bid for it. However, because of the state of things in the world right now, it took several weeks for me to receive my CoCo 2 here in Canada. This was the first of many long delays. Regardless, this is in fact my very first handy Radio Shack computer of any kind. Admittedly, my interests do tend to lean towards other 8-bit retro computer brands of the era, but I truly am looking forward to finally learning more about the Color Computer, and in this case, more specifically, the CoCo 2. So, this is what this video, and possibly video series, is going to be about. 1. Familiarizing myself with the Color Computer 2, both inside and out. 2. Troubleshooting any faults. And 3. Reconditioning the case and keyboard, because, well, they're just nasty. I hope that you will stick with me for this retro computer trash to treasure adventure, and that I can bring this CoCo 2 back to its full operational glory. Now, let's get back to this poor CoCo 2. Well, my very first thought is, shame on you, eBay seller, for this horrid packing job. Just throwing a vintage computer into a box with refuse packing material? Not cool. Thankfully, I don't see any immediately apparent damage, so that's good. This particular CoCo 2 model has a full-height, full-travel keyboard and a cartridge, or should I say ROM pack. Oh, a mystery ROM pack. Also included is an RF video out cable, and as this is a North American NTSC model, we have a 2-prong mains plug with no ground. Now I want to give this computer a thorough look over, and the first words that come to mind are, holy crap, is this thing dirty. The keyboard is super grimy, but at least all the keys are there. The filth shrouds the entire surface of the case. Fortunately, the cartridge port flap is intact, but it's filthy in there too. This really is going to be a trash to treasure adventure. And the backside of the computer, besides being pretty yellow, looks okay. And finally on the bottom, we have the label intact with model number and serial number. This Color Computer 2 model number 26-3127 is a later model that has 64K factory installed, extended color basic factory installed, and the enhanced keyboard. And now it's time to look inside this thing. How does it come apart? 1, 2, 3, 4 screws? Let's start with those. Okay, 4 screws are out. And will it open? No, not yet. Hey, I think there's more screws. Well, of course there are, under the warranty void sticker, which is still intact. That's nice to see. So 2 more screws to remove. In the spirit of full preservation, I wonder if I can get this label off without damaging it and then reapplying it when I'm done. I think it's worth a shot. Let's see if a little bit of heat will soften the adhesive enough for us to get this label off. So I've been at this for a few minutes and I've gotten this far, although this side seems to be stuck on a lot more and it's giving me trouble. Plus, I don't want the plastic to get too hot and it ends up getting damaged. And I ripped it. And I ripped it more. Well, a valiant effort. Anyway, we've revealed the screw under the tamper-proof label, and there's also a 6th screw to remove on the opposite side of the case. Okay, 6 screws have been removed, and I'm pretty sure it's going to come apart now. Aha, nice. Well, the underside of the top cover looks pretty clean. So now let's take a closer look at the motherboard. Starting on the left side of the board, we have what looks to be a power supply circuit and this power transistor that has its heatsink fins bent in. I'm assuming this is done at the factory so that the heatsink doesn't interfere with the keyboard placement. Weird. And just north of that power transistor, we have a transformer with a fuse. We'll have to test that. And the transformer connects to the motherboard with 3 connections. And I also see a large smoothing cap here that isn't bulging, so it's probably okay. And looking at things from this side, we see 2 brown wire connections off of the transformer. I'm going to assume that this is a center tapped transformer, and these are 2 secondary outputs. And now we can see some of the primary ICs. First, we have 2 PIA chips, or peripheral interface adapters, that control the input-output functions of things like the keyboard, cassette, serial ports, joysticks, and even some sound and video. And to the right of those chips, we have the VDG, the Video Display Generator. That one is self-explanatory. In between these primary ICs, we have some logic chips, and they are covered in some greasy grime, as are all of its neighbor chips. And to the immediate right of the VDG is the RF modulator. This is the only native video output option for this computer, so we're going to be using that for now anyway. And taped to the RF modulator is this RF shielding, which is basically foiled cardboard. And to the right of that, we have the CPU. The keyboard is connected to the motherboard with this Mylar ribbon cable that is inserted into this simple connector on the motherboard. And we should be able to disconnect it easily by pulling and wiggling it very carefully, like so. The keyboard ribbon cable and the connector on the motherboard look to be in good condition, so hopefully we don't have any issues with the keyboard. At this point, we can carefully lift the keyboard out, and we have a much better overall view of the motherboard, which we will now unscrew and remove from the bottom part of the case. And for those keeping track, these screws look different than the case screws. Now, are there any other screws to liberate the motherboard? It must be these 2 that are also securing down the cartridge port. And a quick check under here, no other screws. So we'll have to remove those 2 at the cartridge port. Yeah, these 3 motherboard screws are definitely a different size and thread than the case screws, so we'll have to make sure that those go back in the right place when we're done. Okay, now let's get these transformer lugs disconnected. Man, they are on there pretty good. Oh, there's one. There's 2. And last but not least, arg, I cannot get my fingers in there. Needle nose pliers time. And finally, we can lift out the motherboard. And now, free of the case, the motherboard sits sort of flat on my bench, but not quite, because there are two electrolytic caps sticking out of the bottom. I guess the designers figured that having those two caps mounted on the top side of the board would have them too close to the hot power transistor and its heatsink. So anyway, they're on the bottom. Okay, we need to strip this down a little further and get the RF shield off of the bottom and that smaller shield off the top. So how are these secured on here? With clips. Easily removable clips. Well, alright, the RF shielding is free and very golden. So this is just some kind of fancy foil cardboard RF shielding with some kind of amber colored insulating layer on the one side. Our motherboard is finally in the nude. Here's a quick look at the only interesting thing on the underside of the board. It's the power supply section where the two caps are mounted on the bottom. And upon quick inspection, they look to be okay. No bulging, no leaking. And while we're here, here's another look at the large 4700 microfarad filter cap at C2, currently acting as a kickstand. And finally, we have a full clear view of the entire motherboard. And we can take a moment to identify all of the major ICs. On the lower left, in the power supply area of the motherboard, we have the SALT chip. SALT standing for Supply and Level Translator. The SALT chip is a custom IC that does quite a bit for its size. It regulates the plus and minus 5 volts to the computer, but it's also responsible for RS-232 interface level translation, cassette read operations, and driving the cassette relay. So a busy little 16-pin DIP package. Next, we have the two PIA ICs, and as mentioned earlier, those are primarily responsible for device input-output functions. And next, we have the video display generator, or VDG chip. And as the name implies, it's responsible for generating all the video output from the CoCo 2. Along the bottom, we have our 8 DRAM ICs. And again, with this particular model, we have 64K of RAM factory installed. And next we have a pair of 24-pin ICs in the upper right corner of the motherboard that we haven't quite looked at yet. These are the ROM chips. All Color Computer 2 models contain the primary ROM at U12, which contains CPU instructions as well as the BASIC interpreter. But CoCo 2 models that have extended BASIC installed also include the second ROM installed at U13. Below the ROMs we have another interesting IC, the SAM chip, or Synchronous Address Multiplexer. This chip provides refresh and address multiplexing for the DRAM, and it also provides all of the system timing and device selection. And last but not least, we have the main CPU itself, the Motorola MC6809EP. Okay, you got all that? There might be a quiz at the end. Okay, I'm going to set the motherboard aside for a second, and I want to test this transformer. I am a little surprised because there's absolutely no shock hazard protection here at all. Mains connects to the primary side of the transformer with absolutely no protective shielding. I have already tested the fuse with the power unplugged and the fuse is intact. According to the service manual, the secondary of the power transformer should be providing 17.2 volts AC center tapped. We are seeing a higher voltage here at 21.8 volts, but we have to keep in mind this is with no load. So not of great concern at the moment. Now measuring across only one of the secondary outputs, we should see half of the previous voltage measured, which we are 10.9 volts, and across the other secondary, 10.9 volts. So the output voltages are a little bit high, but once again this is not running under load, and that would bring the voltages down a bit. With the transformer appearing relatively safe to use, I now want to inspect the motherboard a little bit more closely to make sure that it looks safe enough to power up. Visually, the electrolytic capacitors look good. I don't see any bulging or leaking. And if I did decide to replace them, there actually aren't too many on the board, so it would be an easy job. About a year ago, I treated myself to one of these Peak Electronic ESR70 capacitor/ESR testers. Not only is it supposed to be quite accurate, but it's very often quite accurate testing electrolytic capacitors in circuit. Well, most of the time. Okay, next on the list is cleaning up this motherboard a little bit. There seems to be a lot of this sort of oily, dusty grime on a lot of the chips on the upper half of the motherboard. And I can see some oxidation or corrosion on some of the dip pins. So I think it's time to get all Gadget UK on this thing. Where are all my cotton buds? If this is going to be a true trash to treasure video, we need to start doing some kind of a cleanup. A lot of elbow grease, cotton buds, and an hour later, this looks a lot better. And now it's time to pull any socketed chips and inspect the legs. That does not sound good. Holy cow, is that in there tight. I am going to switch tools to a chip lifter. That's better, but holy cow, this thing is really in there. There we go. And doesn't look too bad under there, although I do see a little bit of corrosion on a couple of the wipes. Shall we try the chip puller again? Jeez, no. Oh, the one side is free, but this side is super tight. Okay, so that took some extra effort. That did not want to come out. And it might be difficult to see here, but there is some oxidation on a lot of these legs. And the socket itself is a hot mess. Lots of severe corrosion down the one side. I'm going to pull the rest of these chips and store them in an ESD safe box for the time being. There are 4 more primary ICs to pull, and then we'll take a closer look at all these sockets. Okay, I've got almost everything out. Last but not least is the SAM chip, and yes, I'm not using the chip puller anymore. And I'm happy to report this is one of the best looking ones. No issues at all. The VDG chip had the worst socket. I did my best to clean the corrosion off of the connections. However, the corrosion was so bad, we actually have broken wipes. Case in point. Trash to treasure indeed, but more trash at this stage. And I found another broken one on the extended basic ROM socket. Now the chip at U3 here is a custom DAC, and after lifting it out, it too has all kinds of nasty corrosion. Now I can't be sure if the corrosion was caused by a leaky cap, which is just beside it, or that oily grime that seems to be all over the board on the upper half. I've decided to replace all of the dip sockets. I've used a red marker to indicate all the connections that need to be desoldered. And now it's time to warm up the desoldering gun. Desoldering went really well. Now I just need to make sure that all of these pins are actually loose. And now hopefully these sockets will be easy to lift out. Oh yes. Perfect. Now let's get the rest of these out. And all the sockets have been removed, and clearly there's a lot of evidence of pad corrosion. Fortunately, we haven't lifted any pads during the desoldering process, so that's good. I will clean this up as best possible and start to get new sockets in here. Now, if you remember back at U3 where we had that suspect capacitor, I've removed it as well, and there is corrosion underneath the capacitor and on all the legs of the surrounding ICs. However, the 10 microfarad capacitor I removed tested okay, so the corrosion has come from somewhere else. In any case, I've replaced the capacitor with a new one, I have a new socket, and we'll get all the sockets installed. Now let's turn our attention to the ICs that I pulled. I'm using a Q-tip soaked in deoxit, and I'm just going to wipe down all of the individual legs, front and back. This will help remove any oxidation as well as protect the metal. I believe that deoxit D5 also includes a mild lubricant, so it should be easier to reinsert these chips. Now this leg at the end does have some black oxidation, so we might have to use something a little bit more aggressive to get that off, like a fine steel wool cleaning pencil. We can start with this and then move to a finer fiberglass cleaning pencil. Finally, new sockets are installed, chip legs have been cleaned, and it's time to put them back in place. Okay, just two more to go, CPU and the SAM, and then we can power up this thing. Beauty! This little trash to treasure project is coming along nicely. Now, what am I going to output this RF video to? Well, for starters, I have this. An old computer VHF switch box connected to a balun. The RF output from the CoCo 2 plugs into the switch box, and the VHF output goes through the balun and into the cable input of a TV. This TV that I forgot I had tucked away on a shelf. So now we just plug in the 300 ohm to 75 ohm balun into the back of the TV. And our output should be visible on channel 3. Time to connect the transformer back to the motherboard. Connect the RF cable to the modulator. Switch the RF modulator up to channel 3. Make sure our TV is on channel 3. And cross our fingers. Yeesh. That's definitely not normal. It kind of looks like a sync problem. I see color in there a bit. We better turn this off. Now the only thing I have neglected to check is the RF modulator. So let's bust into the can and see if there's anything funky going on in there. And this is the inside of this NTSC RF modulator. I am noticing that a lot of the ceramic disc capacitors have a white powdery film on them. I've seen this on Commodore 64 modulators, and it doesn't seem to have any ill effect on those. The lone IC in the center is a Motorola MC1372 color TV video modulator circuit that generates an RF TV signal from color and luminance signals. And interestingly, the datasheet specifically says it is compatible with the MC6847 video display generator. Yes, that's the exact VDG chip that this CoCo 2 uses. As fascinating as all this is, I think it's time that I take a break from poking around and start educating myself a little bit more. After only a little bit of internet searching, I found the service manual. In fact, the service manual that is particular to my CoCo 2 model. And I have to say, this is 100 pages of very informative information, but a lot to go through. I also thought it would be a good idea to draw on the knowledge of other people, so I joined the CoCo Discord. And I posted some questions there regarding my particular CoCo 2. A lot of the initial feedback was to concentrate on the power supply section of the motherboard, as this can be the root cause of many problems. The advice was to use the power supply check troubleshooting flowchart found on page 85 of the service manual. So that is exactly what I'm going to do. The power supply check flowchart is a very simple step-by-step procedure to ensure that the power supply circuit is functioning normally. Okay, here we go. Step 1. Check for plus 5 volts DC at right end of R2 closest to U1. Here's R2 closest to U1. And let's call it 5.2 volts. Now, is the voltage we measured less than 4.75 volts and greater than 5.25 volts? No, it is not. However, is that voltage greater than 4.75 volts? And yes, it is. And now we continue to procedure A. Now looking at procedure A, step 1 is to check the DC voltage at the collector of Q1. This is Q1, the large power transistor. I do know that 2 leads of this transistor extend through the motherboard to the bottom, but where's the 3rd lead? There should be a base collector and emitter. Well, I have just learned something I didn't know. With transistors in a TO3 package like this one, the metal can itself serves as one of the connections. If we view the bottom of the TO3 package in this orientation, we can see that the 2 leads are actually positioned below the center axis of the can. And now, from this perspective, we can identify the emitter, base, and collector. Again, the metal can is the collector. And now that we're ever so much more knowledgeable, we can get back to our power supply check troubleshooting. The collector of Q1 is measuring 12.3 volts. Now we're asked, is the collector voltage at least 7.5 volts DC? It was over 12 volts, so yes. Next, we need to measure the DC voltage across R2. And now measuring across R2, we get about 66 millivolts. Is our measurement across R2 less than 200 millivolts? Yes, it is. And next we need to measure the DC voltage at U1 pin 1. This is the salt chip again, and pin 1 is the unregulated voltage input from Q1, the power transistor. And we're seeing 6 volts on the input. And if we continue following our flow chart, is the voltage at U1 pin 1 greater than 5.3 volts DC? And yes, it is. And as a result, we are instructed to replace Q1 and then retest. And of course, I don't have a replacement Q1, a Motorola SJ5812. As far as I can tell, this component has been discontinued for some time, and there is little or no data on it. So, what to do? Seeing as we're approaching the 30-minute mark of this video, this might be a good time to take a breather, and I can research replacement components. Yes, components, both what I know I need and might possibly need. But should I actually stop now? Maybe I should push forward. This requires an executive decision. And seeing as it is Septandy, should we take a breather? Haha, so take a breather it is. Actually, I am quite happy that I did accomplish my first goal, which was to familiarize myself with the Color Computer 2, which is, or was, completely foreign to me. And I do think it is wise to stop here for now, do a little bit more research, and then come back to continue troubleshooting and repair, and eventually cleanup. And if you made it this far into the video, thank you very much for sticking around. I appreciate your time. Don't forget to visit all the other channels taking part in Septandy this year, and don't forget to come back for part 2 of this TRS-80 Color Computer 2 Trash to Treasure adventure.
Trash to Treasure is a registered trademark of Retro Man Cave. It may not be used in whole or in part without the express written permission of Retro Man Cave. Unauthorized use is strictly forbidden. Your home may be repossessed if you do not keep up with repayments. Terms and conditions apply.
Oh my gosh. Why?